Now here in 11, we've got a division and multiplication, right? There's no addition subtractions to slow us down. All multiplications and divisions. So let's go ahead and divide. Now, the 4 divided by 2 is a 2. And then what about these x's? Well, the x's, when you make a division, here's the rule we're going to use. If you have x to the n over x to the m, same base, when you multiply, you add the exponents. When you divide, you subtract the exponents. So what I'm going to get is 6 minus 3. And then I've got the y's. Now the y's, same base, so top exponent minus bottom exponent, right? Top minus bottom. So I'm going to get 7 minus 3. So let's conclude that we get 2x cubed y to the 4th. Now if you're interested, here's how it works. The 4 divided by 2 we know is 2. And what about these x's? Well, the x's, we've got 6 on top. 1, 2, 3, 4, 5, 6. And the y's, we've got, oh boy, 7. 1, 2, 3, 4, 5, 6, 7. And on the bottom, we've got 3 x's. And the y's, 3 y's. And then what we can do is we can start canceling. 1, 2, 3. So how many of these x's are left? 3. There's our 3. And what about the y's? 1 goes, another goes, another goes. So how many y's are left? 4, and there's the 4. Number 12, I'm going to do this 2 ways. I'm going to use this rule right here. If you have x to the n divided by x to the m, I subtract exponent, top exponent minus bottom. Now if I do that, I'm going to get this. Notice they have the same base, right? Same base, so we're good. A to the negative 5, top exponent, minus the bottom, 8. So I'll get a to the negative 5 minus 8 is negative 13. Now I'm going to use this rule. I'll do it up here. If you have x to the negative n, you get 1 over x to the positive n. So just flip this over. So I'm going to have 1 over a to the positive 13. Now another way to do this one is right away what I can do is with that I can eliminate the negative exponents, which is sometimes very convenient to do. Sometimes it's hard to work with these. They're challenging to work with negative exponents, so just get rid of it. Now you know this. A to the negative n is equal to 1 over a to the n. So because it's all multiplication division, just drop this thing down. So I can write it like this. 1 over, I already have the a to the 8th. Now just drop this one into the denominator, a to the positive 5. Then I've got 1 over, now I'm multiplying 2 powers with the same base, so I write that base, add the exponents, one over a to the 13. Okay, so I get the same thing I got up here. Just 2 different ways of doing that problem. Now 13 is similar to 12 in this sense. I've got a negative exponent here. Now what I'm going to do is I'm going to change that exponent to a positive by changing the position of the base. So I do 2 things. If I change the position of a base, I have to change the sign of the exponent. In other words, if I change the sign of the exponent, I have to change the position of the base. So I'm going to bring this one up by doing this. I already have that x to the 5th, right? I've already got this one. Now bring this one up. If I change the position from bottom to top, I change the sign of the exponent. All right, now I'm just multiplying 2 powers with the same base, so I just add the exponents, getting x to the 10th. Or I could use the rule directly, x to the 5th, right, take the top exponent minus the bottom exponent, minus negative 5, okay? Top exponent minus bottom exponent, top minus bottom. But this gives us x to the, now, this part here, opposite of negative 5 is positive 5. So I get x to the 10th. So either way, I get an x to the 10th out of that. Now 14, I've got a division raised to a power. Now notice you can actually do something in here, right? I'm going to work inside parentheses first. So what do you get inside here? Now inside, I get x to the, I got a division, so it's the top exponent minus the bottom exponent. The whole thing's to the third power. Now this right here is x to the fifth to the third power. Now I have a power raised to a power. So I just multiply the exponents. X to the 5 times 3, I get x to the 15th. Number 15, we've got a division and multiplication. It's all multiplication and division, no addition, subtractions to slow us down. All right, so first thing I see here is I've got a negative exponent. So what I'm going to do is I'm going to bring this up. Right, just bring that b to the negative 5, bring it up. Get rid of that negative exponent. So it'll look like this now. I'll just rewrite the problem. 5, a to the 7th, b to the 6th, over 15a squared. Now bring that b to the 5th up. So if I bring it up, it's times b to the positive 5. Right, what I did is, remember, you can move things around, move bases around from top to bottom if you just change the sign of the exponent. So the negative 5 will become positive 5, and the b will change positions from bottom to top. Now let's see what we've got here. What can we do? Well, let's see. B to the 6th times b to the 5th is b to the 11th. So I'm going to get 5. A to the 7th, b to the 6 plus 5. I'm just going to do it. 11. 15a squared. Okay, now let's divide what we can here. 5 will go into 5 once, 5 will go into 15 3 times. Now what about these a's? All right, so here's what we're left with. I'm going to have a 3 down in the bottom, and in the top, here's what I've got. I've got a to the 7 minus 2, right, using that rule. 2 powers with the same base, top exponent minus the bottom exponent. And I still got the b to the 11 up here. All right, so now I end up with a to the 5th, b to the 11th, all over 3. And I had that 1 here, but 1 times anything is 1, so I don't really need to write the 1 down there.